Okay, folks, looking like we're probably not having our class tonight, so I made you a video for the last part of the circle notes. So if you have that, you might want to take it out and go ahead and fill these in with me. I've posted the completed notes on Blackboard, but if you're the type who needs to see something done and work through, this is probably going to work for you. So we spent a lot of time in the last class looking at completing the square, and I told you that it would come up in the circle unit, and here it is. And so the first thing I'd like to point out to you is we have a new form of a circle that we're going to be dealing with. So we have standard form already, which is the x minus h squared plus y minus k squared equals r squared. And now we have this new equation up here, x squared plus y squared plus ax plus by plus c equals 0. And this is called the general form of a circle. So general form and standard form, two different forms of circles, but the reality is you can transform one into the other and then the other into the other. I guess that would be the other into the other into the other. But we're going to talk about transforming standard form equations into general form first, and then general form back into standard form. In fact, I said that backwards. We're going to do general to standard first. So as I said, the topic that this is related to is the topic of completing the square, because since standard form equations of a circle require us to square a binomial to get a circle equation from general form to standard form, we must complete the square. So we're going to write complete the square in here. Sorry about that, a little lag on my iPad. So complete the square. And when we look at this equation that is in general form, you'll notice that it's in decreasing power order. In other words, the first couple of terms are the x squared terms. Then you have your 4x and your 6y. So here are your linear terms and then your constant terms. So we need to do a little reordering to do the completing of the square. So the first thing I want to do is get the x's with the x's and the y's with the y's. So here we go. I'm going to take x squared and put it with the 4x. And then I'm going to take the y squared with the negative 6y. And the 12, we can either leave it where it is or we can move it to the other side. And just to be consistent with what we were doing the other day, I'm going to leave it for now. So here we go, just regrouped. And now you'll see that I have two sets of things that I'm going to need to complete the square on. I have an x squared plus 4x that's missing a constant term, and I have a y squared minus 6y that's missing a constant term. So I'm going to focus first on the x squared minus x squared plus 4x. So in the x squared plus 4x term, I need to complete the square by taking half of the b value, which would be half of 4, and squaring it. So half of 4 is 2, squaring it is 4, so I'm going to add 4 to the x squared plus 4 term. At the same time I add 4, I'm going to put a plus 12 over here because we know it's going to appear. I'm going to subtract the 4 off because I have to keep the equation balanced. Now I'm going to do the same thing with the y squared minus 6y term. So when I complete the square on y squared minus 6y, I take half of the negative 6y, which is negative 3, square it is positive 9, add that in. And then I make sure that I subtract it off the end, again, to keep things balanced. And this is all equal to 0. And by doing this, I have now created a perfect square trinomial for both the x's and the y's that can be written as a binomial square. So x squared plus 4x plus 4 can be written as x plus 2 quantity squared. And then y squared minus 6y plus 9 can be written as y minus 3 quantity squared. And then I have a net change over here of 12 minus 4 minus 9. So 12 minus 13, or a negative 1. I am going to move that negative 1 to the other side, in which case it will become positive. And now notice I have a standard form equation. I have a circle that has a center at negative 2 comma 3 with a radius equal to 1. And now if I want to graph that, I can graph it. I can identify things. I can find the x and the y intercepts. I could have done that from the general form equation, but in all honesty, the standard form equation is a much easier one to talk about. So that's all you really have to do. So let's move on to the next page and look at another example. All right, here in example number 6, you'll see the graph that we're going to need to make is of the circle x squared plus y squared minus 6x plus 2y plus 9 equals 0. Again, not a very workable form of the circle, so we're going to convert it back to standard form and see if we can't get it onto our graph. So first thing is reorganize. Get your x's with your x's and your y's with your y's. I don't know if you can see that. I don't know if that's flashing on your screen. It's flashing on my screen, which is really annoying. From here, we're going to complete the square. So I'm going to take the x squared minus 6x and take half of negative 6, which is negative 3, and square it, so plus 9. And then y squared plus 2y, and then complete the square on that. So that's going to be a plus 1. And I added 9 and added 1, so I need to subtract 9 and subtract 1, or subtract 10 from the 9 that's up here. So that's going to be a minus 1, and that equals 0. And again, now I just go to the rewrite where I regroup, and I have x minus 3 squared plus y plus 1 squared, and again moving the negative 1 to the other side equals 1. So again, a center of 3, negative 1, and an r value of 1. And you can go ahead and graph that on your coordinate plane now. This is going to be a little hard for me. 1, 2, 3, negative 1 is down here, and then a radius of 1. It's a really, really tiny circle, kind of like that. So there is the circle x squared plus y squared minus 6x plus 2y plus 9 equals 0. And like I said, we can go back and forth. So all this is completing the square and rewriting things. We can go back and forth between the two forms. So that last example we're going to do is take a standard form and put it into general form. All right, in this final example, we were asked to take a general, or to find the general form of the equation of a circle that's centered at 1, negative 2, that contains the point 4, negative 2. And I always say, like, it's best if maybe you draw yourself a picture. So if we have a center at 1, negative 2, so center at 1, negative 2, so somewhere right around here, and then it contains the point 4, negative 2, so over 4 down 2. We got a circle that looks something like this. And here's our center, and here's our point that we're given. We need to find the general equation of this circle. Well, probably the easiest thing to do is find the standard form version of this equation and then transform it to general. So to do that, probably the first thing we need to do is we need to find a radius, because that's going to be key in our writing of the equation. We already know the center, so just knowing the radius would be good. We'll then write it in standard form, and then we'll convert it to general form. Now, one of the things that drawing the picture does for me is actually shows me that from the center to the point that was mentioned in the problem is actually a horizontal piece. So over 1 down 2 to over 4 down 2 is just a nice horizontal piece that moves from 1 to 4. So without doing really much of anything, I don't need to use the distance formula. I could if I really wanted to, but you'll see that that radius is just length 3, because the difference between 1 and 4 is 3. So I got my r value. My r value is 3. That means that I could write my standard form equation by saying x minus 1 squared plus y plus 2 squared is equal to r squared, which is 9. To then transform this into general form, I need to expand my binomials and move everything to the left-hand side and set it equal to 0. So undoing the factoring, x minus 1 squared is x squared minus 2x plus 1. And then y plus 2 squared is y squared plus 4y plus 4. And I'm going to take the 9 and bring it over via subtraction. And now we have this. Now again, the general form equation is in descending order by powers, so I need to regroup things. So I want to start with my x squared term and then my y squared term. So I've used both of those. Now I'm going to have my negative 2x and my positive 4y. Now I have my linear terms. And finally, I want all of my constants. So I have a positive 1, a positive 4, and a negative 9. So that would be 5 minus 9, which is minus 4, is equal to 0. And that, my friends, is the general form equation of the circle centered at 1, negative 2. That also includes the point 4, negative 2. Hopefully going through and doing some of the My Math Lab examples will get you a little bit better at this. My big suggestion would be writing them down. Do not attempt to do them all just sitting there at the computer. Write down what you have, draw pictures, be careful when completing the square, make sure that you expand properly. Remember that x minus 1 squared is not x squared minus 1 squared. You have to FOIL it out. So if you need to actually do the whole x minus 1 times x minus 1 piece, and remind yourself that you get, the x squared minus x plus 1. That will give you the x squared minus 2x plus 1 that you need. So don't rush through it. You have until Friday night to get it done. Again, I hope you guys have a great break, and I hope you enjoyed the video. And yeah, okay. Be on the lookout if you haven't already in your email for more instructions. I'll talk to you later.